Good morning. My name is Sudhakar. I'm going to teaching about the basic manufacturing technology. In that, we have uh, started the second unit, that is broaching machine. So up to now, we have completed 2 sessions on broaching machines and broaching. Right. Today we are completed our broaching machine topic because it is a very short unit. So that will be ended today itself. Okay. So before going to discussing today's session, uh, what we have learned in yesterday's session, that will be recalled, right? After that, we will move into the today's topic. So yesterday we have started with broaching missions, right? And types of broaching missions. In that, we are having different types of broaching missions. So broaching machine means it is also a machine having but less components. The broaching machine has less components that compared to all other machines. Understood? So the parts are discussed and what are the operations have been done with this broaching machine, and the pulled or pushed type and surface broaching. So these types are maybe doing with that broaching machine that will be discussed in the yesterday's session. And also we are moving to the types of broaching machine. In that, the horizontal broaching machine that may be pushed or pull type, and vertical broaching machine. The second type is continuous broaching machine. In that continuous broaching machine, horizontal continuous broaching machine or maybe rotary table continuous broaching machine, right? So these are the 4 types of broaching machines in the types of broaching machine. In that, we have discussing about the horizontal broaching machine. So that in that we have discussed about the constructional details of the horizontal broaching machine and features of the horizontal broaching machine. Features of the horizontal broaching machine. In horizontal broaching machine, the parts are base, frame, housing, drive mechanism, right, and pilot, broach pilot. So these are the parts in horizontal broaching machine. So the base is the bottommost part of the machine, and it supports all other elements, and it is made with cast iron. We know already every machine base is having this type of points only because it is at the bottom of the machine. That's why the base is the bottommost part of the machine, and it supports all other elements, and it is made up of cast iron material, right? And after that, the other component is housing. Housing means different types of mechanisms are holds in this housing. That may be drive mechanisms or that may be tool holding mechanisms. Okay, so this type of mechanisms are in the machine itself. So that's why it is called as a housing machine. Housing machine, right? Housing. And after that, the drive mechanism. So the drive mechanism is used to drive the machine, used to operate the machine. In this horizontal broaching machine, the cutting tool may be moving, and the workpiece is at a fixed position. So in the horizontal broaching machine, we have observed in the diagram that is the pulled type of horizontal broaching machine. Pulled type of horizontal broaching machine that has been observed in our yesterday's session, right? Okay. So in this, it is operated with the hydraulically. So here the drive is hydraulically. So for this hydraulic sump is situated in the housing of the broaching machine, right? So and after that broach pilot. So broach pilot holds the cutting tool, right? That may be pushed or pulled cutting tool. So that cutting tool is doing the manufacturing process. The cutting tool is removing the material from the surface of the workpiece. So broach tool holds the cutting tool. Broach tool holds the cutting tool. So right. So that is the operation has been done with the horizontal broaching machines, and those are the components of the horizontal broaching machine. Now coming to the features. Features of horizontal broaching machine means it doing surface and internal broaching operations. Generally, it is used for surface and internal broaching operations. So it may be using doing the surface broaching operation, and it may be used for doing the internal broaching operation. So horizontal broaching machine may be used for surface broaching and internal broaching operations, right? Surface broaching means the broach tool is pulled over to the surface of the workpiece. Surface broaching means the broach tool is pulled over the surface of the workpiece. And coming to the internal broaching, the tool, the broach tool is pulled through the workpiece. Pulled through the workpiece. Generally, the broaching horizontal broaching machine is used to manufacturing the keyways, splines, slots, right, round holes, right. So in that keyways, splines, slots, these are all coming to the category of the surface broaching. And coming to the internal broaching, it is used for round hole. So generally, horizontal broaching machines are used for surface broaching operations, right? So generally, these are used for surface broaching operations, right? So now coming to the vertical broaching machine, this will be this has been also discussed in the yesterday session, but in ending session we have learned some of the things of the vertical broaching machine. Now we have started with in detail from the first point onwards. So in the figure itself, we have observed the vertical broaching machine, right? So what are the parts we have to observe in this vertical broaching machine? So here it is having a base, column, slide, broach, fixture, right? So for this column is there because it is vertically operated. So that's why every vertical machine is having a column. With that column, either it may be fixed with the workpiece or it may be fixed with the cutting tool, right? So here in the diagram we have observed that the broach tool is fixed to the column and the workpiece is fixed on the base of the bed. Okay, so base of the bed and it is fixed to the column. So the manufacturing process has been taking place by moving the reciprocating motion of the machine, right? So up and down it is moving to and front. So reciprocating action is there. With that action, the workpiece is moving and cutting tool is moving and the workpiece is machine, right? So in this diagram, we have observed that vertical broaching machine. So that these diagrams also we have observed different types of broaching machines, vertical broaching machines. So in the animation, how the vertical broaching machine is acting. We have observed that here. Look at this. So this is the broaching tool rounding the um, mentioning this round hole. So with we know already that the broaching tools are removing less amount of material. So that's why it is called as a finishing operation, as we have learned in our previous sessions also, right? So this pipe is used for coolant, right? By doing the machining operation, it uses the coolants and also it is guide the cutting tool also. So here we can tell that it may be either push type or pull type. The vertical broaching machine may be push or pull type. In horizontal broaching machine also we have learned that it may be push or pull type. So in the most of the broaching machines are pull type. Pull type is more popular. Main parts of vertical broaching machines are base, column, ram and broach, fixture and table, drive mechanism, right? So we know all the parts already we have observed in the diagram. Base is used to support all the other elements and column is to support the cutting tool, and it supports the RAM also. So with that, in that RAM, the cutting tool is the broach tool is moving. Instead of cutting tool, we can tell that we have to call that the broach tool. So the broach tool is moving on the RAM, right? So on the fixture, on the base of the fixture, fixture and a table on that table fixture is there. On that fixture, we have fixed the workpiece, right? So according to the action of the RAM, the broach tool is moving. That is reciprocating motion. With that reciprocating motion, manufacturing process has been done. Metal removal has been taking place. Less amount of metal is taking place, and the drive mechanism, the part, the drive mechanism is used to move the RAM, right? That may be hydraulically, so hydraulically operated. So that may be used to drive the RAM. If the RAM is moving and the broach tool is moving, so with that broach tool, the manufacturing process has been taken place, right? Three models are available in vertical type: pull up, pull down, push down. Pull up model is most popular. Okay, so in vertical broaching machines, we have different types of models are available: pull up model, pull down model, push down. Pull up, pull down, and push down, right? In this, we are using most popularly pull up model is used, and the broach is securely held in RAM, right? And it occupies less floor space, right? So three models are available in vertical type: pull up, pull down, push down. And this pull up model is most popular, and the approach is securely held in RAM and occupies less floor space. Modern vertical machines are available with hydraulic drive, electromechanical drive. Okay, hydraulic drive machines cost is less and requires flat form or pit for the operator. Convenient to pass work from one machine to another. In this, we know the drive mechanisms of the vertical broaching machine. So modern vertical broaching machines are available with hydraulic drive and electromechanical. Hydraulic drive and electromechanical drive. Hydraulic drive machine cost is less, but it is required platform or pit for the operator. To operate this vertical broaching machine, to stand up for the operator, some platform is needed or a pit is needed to operate that hydraulic vertical broaching machine, right? So if we have this, it is convenient to pass work from one machine to another, right? If this platform is there, it is available there, we can easily pass work from one machine to another, right? So these are the things in the vertical broaching machine. So it may be available with hydraulic drive or electromechanical drive, right? And employed in multiple operations. If it is passed one or the other, so we can do the multiple operations also. The duplex head broaching machines. So observe here, these are the ram heads. With these ram heads, we have fixed the broach tools. Here the workpiece. So we can operate on both sides. So we are operating both sides. So while operating these both sides, the manufacturing is done on the both sides. The metal removal has been taking place on both sides. So metal removal has been taking place on both sides, right? So vertical broaching machine doing the work, and it is also doing the work like this, and the table is there. So here the material has been taking place. Two RAMs will be provided on some machines. Such machines are called duplex head machines. As we have observed in the diagram, these are called duplex head machines. Two RAMs will be provided. Next, what is a duplex head broaching machine? Machine with two heads. So machine with two heads, we can call it as a duplex head broaching machine. Simultaneously, two surfaces can be machined. Mostly push type machines. These are mostly push type machines, and these are commonly employed for surface broaching, and rate of production is high. right? So machine with two heads, simultaneously two surfaces can be machined that we have observed in the diagram. And mostly these are push type of machines and commonly employed for surface broaching operations. And the rate of production is high. Production rate is high by doing the duplex head broaching machine, right? So in this session, yesterday's session and today's session, we have concluded that broaching machine, classification of broaching machines, constructional details of horizontal broaching machine, vertical broaching machine. Based on this, we can do some discussions on this. Broaching machine with two broaches working simultaneously is called duplex broaching machines. In broaching machine, maximum amount of stock that can be removed is 2 mm, 4 mm, 5 mm, 6 mm. Maximum amount we know that is 6 mm. Okay, so we have to conclude this, and we are going to another topic today, right? Now we are moving to today's session, right? On completion of this session, we will be able to know about the working of continuous broaching machine, specifications of broaching machine, broaching operations, nomenclature of broach tooth, advantages and limitations of broach. Right. So in the yesterday's class, in our first session, we have discussed that the working of the working of horizontal broaching machine, vertical broaching machine. In vertical broaching machine, duplex broaching machine also is there. The duplex broaching machine has two heads, so it working on both sides that we have observed in the diagram, and it is having two rams. So with the two rams, it can be doing the manufacturing. Understood? So now we are moving to the working of another broaching machines. We have discussed that the types of broaching machines yesterday: horizontal, vertical, continuous broaching machines. In continuous broaching machines, a rotary table broaching machine is there, and a horizontal broaching machine is there, right? So that has to be discussed in today's session. So in this session, working of continuous broaching machine, specifications of broaching machine, broaching operations, nomenclature of broach tool, advantages and limitations of broach. Advantages and limitations of broach. Continuous broaching machines, right? It is used for mass production of small parts. Continuous broaching machines are used for mass production of small parts. We know that already. Mass production means the number of products are high. Number of products are high. That means identical parts, similar parts. So same parts are produced in high range. That is called as a mass production. Okay. So in continuous broaching machines, we have used it to produce the small parts, but in mass production. In mass production. So there are two types. Rotary continuous broaching machine, horizontal continuous broaching machine. In both machines, there are two types of broaching machines. One is rotary continuous broaching machine and horizontal continuous broaching machine. The name itself tells us that rotary continuous broaching machine means there is some circular motion or rotary table is there. With that, workpieces are moving, and at one place the cutting tool is, the broach tool is held stationary. After passing through this rotary approach tool, the manufacturing has been, the material removal has been taking place. So with that, we are getting the production, right? So that will be, we can tell that with the rotary movement of the broaching machine. And coming to the horizontal continuous broaching machine. In horizontal continuous broaching machine, there is a movement horizontally. Pieces are moved on one by one, right? The cutting tool is currently stationary at one place, so machining has been taking place while passing through the work, right? While passing through the cutting tool. Okay, so these are the two types, right? And we can tell that easily these in both machines. These both machines, broach is stationary and the workpieces move across broach, right? In this, we have observed that the broach is stationary and the workpieces move across each broach. So we are telling that in the operations of the broaching machine, in surface broaching, the broach and cutting tool, broach and workpiece both are moving across each other. But in push and pull type and in continuous broaching machines, we have observed in the diagram, right? So the broach is fixed at one position and the workpieces are moving across the broach. That we have observed in the continuous broaching operations. Continuous broaching operations. Now we are discussing about the continuous broaching machines. So these continuous broaching machines are used for small parts. And they are of two types: rotary continuous broaching machine, horizontal continuous broaching machine. In both machines, the broach is stationary and the workpieces move across broach. So rotary continuous broach machine, rotary continuous broaching machine. So here one is the workpiece and second one is the rotary table and it is the broach. Okay. So here we can easily understand by this diagram. So the workpieces are rotating on this table, rotating on this table. At somewhere the broach tool is fixed. At somewhere the broach tool is fixed. So these broaches, these workpieces, while passing through this broach tool, the machining process has been taking place. The material removal has been taking place. After the material removal, we can unload the workpiece from that circular table. We can unload the workpiece from the circular table. While doing the operation, we have to load the workpiece on the rotary table. And after doing the manufacturing operations, after doing the machining operations, we have to remove the workpiece from the rotary table. So then we can get the finished product from the rotary table. So we have unfinished products are rotated on the table and the finished product has to be unloaded from that rotary table. So that is, we have clearly observed in this diagram, rotary continuous broaching machine. In that, we have observed only three parts. One is the workpiece, and second one the rotary table, and the third one is the broach, right? So, features. So, features means what are the operations, what are the specialities in the continuous broaching machine. So, that we will be discussing now. The features in the workpieces are loaded on the table. Here, the workpieces are loaded on the table. We know that already we have observed in the diagram. Table rotates continuously. The table is rotated continuously. So, during broaching, broach is stationary. So, we have observed in the diagram that during broaching operation is done, the broach is stationary and workpieces are held in pictures. Workpieces are held in pictures. So workpieces come into contact with the broach, loading and unloading them on the table. It is a surface machining operation. So by doing this, we are getting the heavy production rate, right? As we have already taught that about the rotary continuous broaching machine on the rotary table. So the workpieces are held loaded on the table. Workpieces are loaded on the table and table rotates continuously. Table is rotating continuously. During broaching, broach is stationary, right? And the workpieces are held in pictures. So table rotates continuously with the required speed, and during broaching, broach is stationary. As we have observed in the diagram, the broach is fixed at somewhere and it is in fixed position. While passing many workpieces through this broach tool, the broach tool is not going to vibrate. The broach tool is not going to vibrate. So that's why we have fixed this broach tool at somewhere itself. Okay. So workpieces are held in pictures. Workpieces are held in pictures. Uh, and workpieces come into contact with the workpiece is come into contact with the broach. So loading and unloading done on the table. So the loading and unloading done on the table. So in the diagram we have observed that it is a continuous process. It is a surface listening operation. So heavy production rate is done. Heavy production rate is done by this rotary continuous broaching machines. Workpieces are held or loaded on the table, right? So table rotates continuously. So in the diagram, we have observed that the circular motion of the horizontal continuous broaching machine. Horizontal continuous broaching, we have two wheels are there. So workpieces are fixed on the line. So it is rotated continuously. The workpieces are rotated continuously and the cutting tool is fixed at somewhere. So these workpieces are passed through that broach tool. In the diagram, we have observed clearly that the workpieces are passed through this cutting tool and the machine process has been taking place. So while doing the machining operation, the machine, while doing the machining operation, the material removal process has been taking place. The material removal in the form of chips, and here we can observe that the direction, right? So in this we can observe that the direction, the rotation has been taking place like this. Here, the first part is the broach, and the second one are the workpieces. So here, the circular motion is there. Circular motion is there. So due to the circular motion, material removal is taking place. Material removal is taking place. So with this, we have getting the finished product from raw material. So we have fixed that finished on raw material in this chain, endless chain. So continuously we are getting that unfinished product from that chain, unfinished product from that chain. Okay. Continuously we are getting the finished product from that chain. We are loading and unloading the workpieces while doing the operations on the horizontal continuous broaching machine that we have observed in the diagram. Okay, in the simple things we have tell that there is a circular motion is there, right? So in that circular motion, we have fixed the work pieces on that circular motion, and the cutting tool is fixed at one position, broach tool. So if we want to do the machining operation, so the rotation is going to take place. So due to this rotation, the work pieces are moving through that chain. So the broach tool is doing the machining operation, and the material removal process has been done. After that, we are getting the finished product that will be observed in the diagram, right? So in the horizontal continuous broaching machine, as we have discussed already these points, the workpieces are carried by endless chain, and the endless chain we have observed, and the chain carries work holding fixture. This chain carries work holding fixture. So here we have to fix the workpiece in a fixed position, right? There is no need to generate the vibrational effects on the workpieces. So that should be fixed. The workpieces should be fixed on the fixtures, right? So here the endless chain carries work holding fixtures, and workpieces are placed in fixtures. Workpieces are placed in fixtures, right? So workpieces are placed in fixtures, so there is no loosening of the workpieces, so they are continuously moving, and there is no side movement of the workpieces, so they are continuously moving on that chain, right? So that broach is held stationary. Here the broach is held stationary, and that we have observed in the diagram. When chain rotates, the workpieces moves against the stationary broach. So that's also we have observed in the diagram. It is a surface broaching operation also. Heavy production rate is been getting with this horizontal continuous broaching machine. Okay. In the rotary continuous broaching machine, the rotary table is there. Based on the diameter of the rotary table, we can fix the workpieces, right? So here the less floor space is also occupied based on the table diameter. Coming to the continuous broaching machine, here one chain is there, endless chain is there. In that endless chain, there is some circular motion has been taking place. Fixtures also there. With that fixtures, the workpiece, the cutting tool, and the workpieces are moving, and the manufacturing and process has been taken. Okay. So these are the horizontal continuous broaching motions and rotary continuous broaching motions, right? So these are all about the types of the machines, types of the broaching machines: horizontal broaching machine, vertical broaching machine, right? Rotary table continuous broaching machine and horizontal. So specifications of broaching machines, right? So about the specifications of lathe also we have learned, right? So these specifications are needed uh, when these are needed means if we are doing some particular operations or some particular workpieces, so based on that requirements, based on that workpiece requirements, specifications of the machines are needed. Specifications of the machines are needed, right? Here, broaching machine specifications. So the specified parameters to be specified are broaching speed. Here, the broaching speed means tool speed. In this broaching tool speed, we have observed that in yesterday's session, while doing the cutting stroke, the speed should be minimum. While in the return stroke, the speed should be less. Sorry, the speed should be more. By doing the cutting stroke, the speed should be minimum, and while in the return stroke, the cutting stroke is more. Okay. So, because if in the cutting stroke there is a contact between the workpiece and the cutting broaching tool. So, with this, what happens? So, there is heat affected maybe increases, heat affected zone is increases, and the tool and the workpiece may be damaged with high force. Okay. So, for this reason, while doing the cutting stroke, we are doing the minimum speed. But in return stroke, it is ideal stroke because there is no uh, cutting, there is no cutting has been taking place. So that's why it is an ideal stroke. So that's why we are providing with that high speed. With that high speed, we are reducing the time. We have reducing the time, so we can do that operation. So right. So the broaching speed is the cutting speed, and return speed is the return stroke of the machine. And machine horsepower, floor space required, and HP of the motor, horsepower of the motor. So these are the parameters to be specified of the broaching machine. Before that, some specifications are main specifications are length of stroke in mm, right? Length of stroke in mm. So this means with one stroke, how much material has been removed. How much material has been removed from the workpiece. So this can be tell that length of stroke, right? So and force that can be applied to broach in tons. Force that can be applied to broach in tons. So how much force is applied to broach in tons is also one of the specification that we have needed. So here the length of stroke in minimum mm. For example, broaching machine with the specifications 1000 N means machine has 1000 mm stroke length and 10 tons broach driving force. So here the specifications only two are length of stroke in mm and force that can be applied it to broach in tons, right? So broaching machine with specification 1010 means machine has 1000 stroke length and 10 tons broach driving force. So here 1000. So the broaching machine with the specifications of 1010 means the broaching machine has 1000 stroke length and 10 tons broach driving force. Okay, and specifications. Other parameters to be specified are broaching speed, return speed, machine horsepower, floor space required, horsepower of the motor. Right. So we know already that the broaching speed means it is a cutting speed, cutting stroke has been taking place, and the return speed. Return speed means it is the ideal stroke, so it should be high. Machine horsepower, floor space required, and horsepower of the motor. Right? So these are the specifications of broaching machines. And the broaching operations are broaching operations is applied for internal and external surfaces, round and irregular shaped holes of 6 to 100 mm diameter, flat and contoured surfaces. Most operations are completed with one pass of the broach. So these are the broach operations applied. Okay. Broaching is applied for internal and external surfaces. Round and irregular shaped holes of 6 to up to 100 mm diameter into the internal operations also. Round and irregular shaped holes. And flat and contoured surfaces. Flat operations and contoured surfaces also done by this broaching machine. And in this broaching operations, most of the operations are completed with one pass of the broach. That we have already told that broach is the broaching is the minimum amount material removal. So we can easily remove the material, small amount of material. So that's why we can tell that this point most operations are completed with one pass of the broach. Okay. In all broaching operations, as we have observed that work is held in a fixture, right? Tool is held in a tool head, that may be pulling or pushing head. Either work tool or tool move across each other. Okay? So these are the points we have covered in all broaching operations. That is, work is held in a fixture, tool is held in a tool head, pulling or pushing head, either work or tool move across each other. So workpiece is fixed in a fixture. We know already that fixtures are the work holding devices. They are formally fixed the workpieces in that, right? So with that, while doing the operations, if any workpieces, if any vibrational effects are produced, the workpiece may not coming out from the operation because it is firmly fixed in the fixture. So we have observed in all operations the workpiece is held in a fixture, right? And after that, tool is held in a tool head, that may be pulling or pushing head. So in the all broaching machine, the tool is held in a tool head. So the tool head may be pulling or pushing type. Okay. So sometimes based on the operations, it may be doing pulling operation or sometimes doing pushing head operation. Right? Okay. Finally, we can tell that the tool is held in a tool head. And either after these fixtures, after these fixings, work tool and workpiece and tool, both are fixed in fixed region. Either work or tool move across each other. Either work tool may be moved or tool move across each other. So in pushing or pull type operations, the work workpiece is fixed and the cutting tool is moving on the workpiece, right? But coming to the surface broaching operations, we have observed there the cutting tool is held in a tool head and the workpiece is held in a fixture. Both are fixed in a position, but while doing the operations, both are across each other. So the points have been observed in that operations, right? After that, in continuous broaching operations, the workpiece is fixed, the cutting tool, the tool is fixed at one place, and the workpieces are moved across the broach tool. So that points have been observed in that on the operations. In this, we can observe that external broaching on the surface and external broaching on three surfaces, right? So here one surface, so this is the workpiece, and here we are having the surface. So primary cutting motion. So the broach tool is doing the operation. The broach tool is moving in this direction. So with this direction, the material removal is taking place while doing the operations. So it is the external broaching on the surface, right? And coming to here, the workpiece is here. This is the workpiece. So to do the surface operation, the broach tool is like this. So the broach tool is like this. So broach tool is doing the operation like this. Okay, that we have observed. And here in this diagram, we have observed that the broaching of round hole. Broaching of round hole. So these are the workpieces. These are the workpieces. Primary cutting motion and broach. And this is the workpiece. Internal broaching of a round hole. Cutting edges. Okay. So primary cutting motion. So here the cutting tool, the broach tool is moving through this hole. So what are the diameter is coincide with this hole? That diameter cutting edges are removing the material from the surface of the workpiece, right? From the internal surface of the workpiece. So these cutting edges are used for the suit the diameter of this cutting edges. So here in this diagram we have observed that it is going up to here, and the remaining diameter cutting edges are not moving through this round hole, because if it is moving through this round hole, the diameter of the internal surface has been changed. The entire process is going wrong. So that's why broaching of round hole is done like this, and broaching of keyway. So here the keyways, that means the slots. So the slots also done by this broaching machine, right? So here the broach tool and the workpiece. The broach tool is moving like this. Broach of splines. So the number of slots on the shaft, we can tell that splines. So it can be tell as a spline shaft. So for this spline shaft, the material removal has been taking place like this with this broach tool. So the primary cutting motion. So this is the side view and this is the front view of the broaching of this spline. So these are the work pieces. Okay. So for that we are moving the broach tool according to that only. So nomenclature of broach tooth. So here the broach tooth is having this is called as a radius, and the distance between the two cutting edges is called pitch, and it is the rake or hook angle, and it's the depth of cut, and it is the land. This space is called a land, and here is the back of clearance angle. So pitch is the linear distance between the cutting edge of one tooth and corresponding edge on the next tooth, that can be called as a pitch. And land, top portion of the tool, you can call it as a top portion of the tool, ground to provide a slight clearance. Back of, it is the clearance angle of broach. Its value vary from 0.5 degrees to 20 degrees. Rake angle, it corresponds to rake angle of the lathe tool. Okay, land is the top portion of the tool. Ground to provide a slight clearance. Back of, it is the clearance angle of broach. Its value vary from 0.5 degrees to 20 degrees rake angle. It corresponds to rake angle of the blade tube. Its value increases as ductility increases. So advantages of broaching is it is the rate of production is high, less skilled worker can be employed, high accuracy can be obtained, high surface finish can be obtained, and rough and finish cut both are completed in one pass. Both internal and external surfaces can be machined. Any form that can be reproduced on broach can be machined. Cutting fluid may be readily applied. Life of broach tool is high. Cutting temperature and tool varies low. Cutting force acts in clamping direction. Process can be semi or fully automated. But some of the limitations of broaching are high tool cost, economically only for mass production. Sharpening is difficult and expensive, not suitable for very large workpieces. Surfaces should not have obstructions, cannot remove large amount of stock. Very light and delicate jobs cannot be broached. Right? Let us summarize, and we have learned that the working of continuous broaching machine, specifications of broaching machine, broaching operations, and the nomenclature of broach tool, advantages and limitations of broach. Right? So while doing some questions, operation which completes in one pass, turning, filing, broaching, shaping, broaching. So broaching machine with two broaches working simultaneously is called the duplex broaching machine. Which among the following is short and stocky? Push broach, pull broach, note of the above. Push broach is the sharp, right? So these are the frequently asked questions. So with this, I have concluded the broaching machines. In these broaching machines, we have learned that what is broach tool, what is broaching, right? So after that, we are moving to the broaching operations, types of broaching operations, and now after that, we are moving to the broaching machines, types of broaching machines, and after that, we have learned the broaching machines and advantages and limitations of broaching machines. Okay, so I'm closing this broaching machine topic because it is a short lesson, right? So with this, I'm closing this session also today.